2. Vertical motion under gravity. In experiment 2E, the acceleration due to gravity is studied using a motion sensor connected to the data logger interface. The velocity time graph of the motion of the basketball is shown on the computer screen. The basketball is released under the motion sensor and it bounces several times before it comes to a rest. And the velocity time graph repeats in a similar manner for several times, as shown in figure B below. The motion starts when the basketball is let go. It falls under gravity, so AB represents a downward motion. When the velocity increases from 0 to the maximum positive velocity, which points downward, the slope of AB will equal to the acceleration due to gravity. From B to D, the velocity changes its direction from downward to upward. So BCD represents the first rebound. B is the point when the ball just touches the ground, and D is the point the ball is about to leave the ground, and C is the point when the ball is distorted most and the ball is instantaneous at rest. The slope of BD is the upward acceleration during the rebound. From D to E, the ball leaves the ground and moves upward until it is at the maximum height at the point E. At that time, the velocity becomes 0 again, and we say that it is instantaneous at rest. From E to F, the ball falls again, just like in AB. So, the acceleration due to gravity is the slope given by the line AB, or dF. The velocity time graph almost repeats itself, with its amplitude decreases with time. In other words, the maximum velocity decreases from one rebound to another, and hence the height of the rebound also decreases from one rebound to another. Well, what about the displacement time graph? What would it look like? You may find one on page 87. The illustration on page 75 is something that you must not miss. It talks about a ball which is projected vertically upward with an initial velocity of 30 meters per second. Its velocity decreases by 10 meters per second, so that it changes from 30 to 20 to 10 to 0, and then to -10, -20, and finally -30 meters per second in the next 6 seconds. In other words, it takes 3 seconds to move upward and then 3 seconds to move downward. As the acceleration is always 10 meters per second squared downward in a 6-second flight, the velocity time graph is a straight line that cuts the time axis at t equals to 3 seconds when it is at the top of its flight. At that time, it was instantaneous at rest. The yellow area refers to the upward displacement, while the pink area refers to the downward displacement. The two areas are the same because the mass falls back to the same height. In some other cases, the two areas can be different. Example 13 is a more complicated example, making use of the equation for uniformly accelerated motion. In part B, you are asked to find time t. You have to solve a quadratic equation in that case. Spend a few minutes on the solution of this question. Lastly, Try checkpoint 8 on the next page.